Under the Mobil Serv offer, this video is a piece of the on-the-job training curriculum for air compressor inspection. The goal is to enable you to convert customer needs and opportunities around these activities into improvements in safety, environmental impacts, and productivity. The video is the first part of the OJT curriculum. After viewing it, you should job shadow a competent person conducting an inspection. Then have the competent person observe and coach you as you complete an inspection. The OJT Participants Guide provides an effective way to guide the trainer and trainee through the experiences to gain knowledge and capability. Rob, a lube engineer for ExxonMobil, has been working with this existing customer on a number of Mobil planned engineering service projects. John, his contact at the mill, tells Rob that he'd like them to focus on compressor availability and improvement opportunities. Both Rob and John believe that an air compressor inspection can aid in understanding the root cause of some problems John has seen. Rob works with John to understand the impacts of any lubrication problems so he can later use this information to show how his findings and recommendations can reduce these impacts and produce value for the customer. For some customers, Rob performs routine air compressor inspections to proactively look for improvement opportunities or to detect abnormal operating conditions. In addition, Rob may conduct specific inspections to address a specific air compressor equipment reliability issue. To help bring solutions and value to his customer, Rob must be an excellent detective and must collect the data needed to help determine the root cause of any compressor problems. Before meeting John again for the inspection, Rob gathers background information: equipment manufacturer, hours of use, RPM and reservoir capacity, oil filter life and oil separator life, repair history and costs, vibration analysis history, and previous inspection results. Rob also reviews previous used oil analysis for oil condition and signs of wear and contamination. Then just before his site visit, Rob goes over his safety preparations, like customer site-specific training. Many locations have, at minimum, a visitor orientation video. He also reads through the Job Safety Analysis, or JSA, to review the risks and determine the best mitigation steps, including personal protective equipment, PPE. He also takes a moment to refresh his awareness of these life-saving rules and how they may apply to his activities that day. He will isolate energized systems, protect himself against falls, and maintain visibility of key hazards. He prepares and reviews his toolkit, including clipboard or tablet PC or iPad, air compressor inspection worksheet, infrared temperature gun or smartphone Seek thermal unit, flashlight, sample thief, bottles and labels, air leak detection device, digital camera, rags, and black electrical tape.
Hey, John.
Rob, good to see you.
On the morning of the site visit, Rob and John review their goals for the visit. First and foremost, to identify any potentially critical conditions. Rob lists the steps he'll go through.
Annotate all the operating parameters, take some temperatures, do a leak detection, focus on some storage and handling, how you're applying the lubricants, just so we can understand how those compressors are running.
They will look for ways to improve uptime, per their earlier PES planning session.
Excellent. I've got a technician set up to spend some time with you out there, taking you through the systems and kind of showing you around.
Rob goes over his safety plan, and together they review the personal protective equipment he'll need: hard hat, safety glasses, hearing protection, fire-resistant suit if required, gloves, and safety shoes. Rob starts his inspection by recording the make, model, and operating data specific to this SSR rotary screw Ingersoll Rand compressor. With the compressor still running, Rob checks the operating data: temperatures, pressure differentials on the oil filter, discharge pressure of the compressor, oil temperatures, and operating hours. He will correlate these with what he actually sees during the inspection. He looks at the sight glass at the air oil separator to check the oil level of the compressor. Rob always keeps his head in the safety mode during his inspection. He notes this warning about high temperatures in the compressor, which points out the importance of the safety gloves he is wearing. And always, he is looking for oil leaks on the compressor. Here, he's looking across the compressor at the power unit and the screws. Rob looks at this oil scavenge line coming out of the air oil separator. He knows it's important to make sure it is functioning correctly. If there are any leaks or this line gets stopped up, the oil system wouldn't function properly. He notices that the 90-degree connection coming out of the top of the separator is cocked over to the side, in jeopardy of breaking off. This compressor vibrates so much, even in normal operation, that incorrect positioning of that fitting could lead to a breakage, which could shut down the compressor and lead to operational problems. Then moving to the back of the compressor, Rob looks at the top of the air oil separator, checking for leaks. He takes temperatures around the air power unit. He'll use his infrared gun to take temperatures at several points in the system, including inlet and outlet temperatures from each compressor stage, reservoir temperature, motor temperatures, and oil in versus oil out at heat exchangers. Rob takes a moment to write down his temperature readings. Again, notice the PPE that he is wearing: earplugs, safety glasses, hard hat, gloves appropriate for handling the oil, assuming that it's cool, and fire-resistant clothing appropriate for this type of customer. Before taking an oil sample, Rob heeds this reminder that you need to be very careful around very high-pressure systems. Before opening a line, he'll need to make sure that all the pressure has been relieved from the system and that the oil has cooled down. Here, he's using a sample thief to pull a representative sample of lube oil after it's cooled down from the air oil separator. A helper is guiding the sample tube just to make sure it's not hitting the bottom. Rob fills and purges the sample bottle twice before drawing the representative sample. He'll visually inspect the sample for water, sediment, and color. This notice on the air compressor shows that Ingersoll Rand recommends their own coolant. We at Exxon Mobil feel comfortable making recommendations on our own. We work with each customer to ensure that our lubricants meet their needs, both within warranty and after. We have done this successfully for many, many years. Rob is now looking at the air filter on top of the power unit. This is the air inlet going into the compressor. He's making sure that there's a good seal on that air filter. Otherwise, dirt can get inside, leading to premature abrasive wear in the compressor. In this case, Rob notices that the outer air filter housing is missing. He makes a note to recommend that his customer replace it to better protect the air filter. This is the heat exchanger, where the oil is cooled after going through the filter. You can see in the background that the cooling fans are actually plugged up with dirt and debris. This should be blown out with compressed air and kept clean. Otherwise, you will not get the required temperature reduction in the oil. That can lead to overheating of the oil, oxidizing it, thickening it up, and could result in poor compressor operation and eventually compressor failure. So this is an important, simple thing to check. For Rob's next step in his inspection, he'll check for air leaks using this ultrasonic leak detector. This headset helps Rob detect the high-pitched noise of leaks. Filtering on the device helps him pinpoint the source of any air leak. Air leaks put an excessive burden on the compressor and its lubricant. If you can reduce leaks, your compressor is going to run a lot longer. Plus, it saves energy. Rob follows compressor lines going into these gauges and finds leaks coming out of the gauges. These need to be corrected. Rob's normal process after finding leaks would be to estimate their severity, tag them, and enter them in his report to the customer so that they could be fixed at a later date. Remember when Rob outlined his plans for the day, he included taking a look at storage and handling.
Do a leak detection, focus on some storage and handling, how you're applying the lubricants, just so we can understand how those compressors are running.
And here's what he finds. As you can see, this lubricant is not stored in a very clean area. It should either have a drum cover or be kept in an area that is clean. Here's an opportunity to help the customer, because if this type of dirt gets into that drum of lubricant and into the compressor power unit, it can lead to abrasive wear, sludge, and shortened equipment life. At the end of the day, Rob meets again with John. He reviews his activities and notes that he found a significant air leak in the number 4 compressor at the receiver.
So we tagged that for you, and Bill's aware of that. So he's going to get back with you to maybe get a crew on that the next time you can take that compressor down.
Excellent.
Rob tells John that he will combine his findings, including measurements and photos, to prepare an engineering service report for John and his supervisors. He must take in all the facts and sequence of events to determine potential root causes of any problems he finds. He must work with his customer in cooperation, not only to gather the information, but to form the recommendations that will produce an excellent return on investment and value to his customer. Rob and his sales advisor will use this report to promote our value to other key contacts at this customer. In addition to helping this customer in this one application, Rob and his sales advisor will look to see how they can help the customer apply what they have learned to other similar situations at this facility or across their entire company. If very well received, this engineering service report could become the foundation of a proof of performance from this customer that could be used to show other customers to convince them that ExxonMobil and its distributors are the right lubricant supplier for them. By using the standard operating procedure as a guide, as well as the other tools described, Rob can consistently conduct these services and deliver outstanding value to his customer.